Hello folks, this is tutorial number 28, which is dealing with the kinematics scenario creation in 3D Experience, and it's dealing particularly with a universal joint. The difference between this tutorial and the one that's 27 is that there I did not model the cross pin. However, here I will model it and show you what the issues that are going to arise are. Now, it is the geometry is pretty much the same as what we did before, except that there is these grips at the ends where the crosswind is going to go. So we're going to use axis-based universal joint. There's going to be a cylindrical joint here, which is going to be the driven shaft, a revolute joint there, which is going to be the driver shaft. And because the crosswind is modeled, we're going to have two cylindrical joints which are making the pin to move. Okay, I've separated the stuff here so you can see it. There is a ground which has the two bearings in it. There is a driven shaft, there is a driver shaft, and these are identical. Therefore, I make only one and then use an instance of it using multi-instantiation. And then there's the cross pin, and there's going to be two cylindrical joint because of the cross that you see here. Okay. This is chapter 9 of the tutorial book that I wrote 9 years ago, and I haven't updated it. Therefore, I'm doing these tutorials for it instead. Remember, in tutorial 27, we created the cylindrical joint, axis of the shaft and axis of the bearing. And then we did the revolute joint, which is fairly straightforward, axis, the two axes of the bearing and the shaft, and planes of the shaft and the driver shaft and the bearing, and the angle, which actually controls the motion of the revolute joint. And finally, the universal joint is made out of the two axis system that we are going to be creating for them. Now, these uh, things that you see here, these icons, are not explained in the help manual of the 3D experience, and therefore things don't work out. One of the things that you might want to look at is the possibility of different combinations. But anyway, you will see that there are issues when you do universal joint and you do the cylindrical joint for the driver pin. You see that, and we'll talk about it in the video. All right. Good luck. Okay, let me start with an assembly file. The first thing I'm going to do is, ignoring all dimensions, make a shaft which is a bit more complicated than just straightforward cylinder. Okay, right click, insert 3D part, and I'm going to call this thing the shaft. All right, let's go make it. So on the horizontal plane, I will sketch a circle, exit, pad it by some amount. Let me make this thing 120 millimeter. Okay. Then uh, at maybe a little bit longer, maybe 150. Okay. These dimensions don't mean anything, but I'll stick to them. So on that vertical plane, I will sketch, okay, uh, basically the thing that's going to hold the cross pin. And how does that work? So, for example, something like so. We'll clean it up in a minute. This is the grip that's going to hold that crosspin. We'll just clean it up. So for example, left line, control right line, control the middle axis. I'm going to make it nice and symmetric. Okay. Same thing with the inside. Left line, control right line, control the middle axis, symmetric. Okay, and then we make these things coincident. So this line, control that line, we make them coincident to have them at the same height. Okay, good. All right, and now we're going to exit and pad it. We make this thing symmetric on both sides. Well, that's too much. How about making it maybe 10? See how it looks like? Yeah, that looks fine. Okay, now I need a hole there. So on that plane, I will sketch. This is where the crosspin is going to go. I'll try to make it nice and symmetric here. Exit. And then we do a pocket all the way to the end. Up to last, maybe. Yeah. Okay, good. Now what I want to do is I will create a point exactly halfway between the centers of these two circles. So this is what we're going to do. We're going to make a point. And there are different ways of doing it. So this is how I'm going to go about doing it between 2 points. For the first point, I'm going to use uh, this point, but it's going to be the center. Let me see if I can get it. Uh, Maybe create center of gravity. Let's see if it works. So can I select that edge? Yep. So, oh, that's not going to work. Okay. So let me create a point, 2 points. Well, I want to point exactly halfway between these two, and the different ways of doing it. For example, I can go to a point. Well, I'll make the center of these two circles first. Center of these two circles. So this circle, and another one on the other side. Another point at the center of this circle. And then we do a point between these two, exactly halfway between these two. So that's going to be between this point and that point. Okay. This may look familiar to you because if you look at tutorial 27, what I did is I created an axis system there, and I'm going to do exactly that. So axis system, the center of it is going to be right there, and say OK. So the only difference between so far what I've done in tutorial 26 and this tutorial is that there I did not create that upper portion, I just did a piece of the cylinder, the shaft. Okay. Now, what we do is I'm going to just leave everything the way it is. Why don't I need another piece of that? So let me go to the top and click on the next line on the shaft. See that? I'm right there on the shaft. Click on it, and I'm going to instantiate that. And this is good. So I need two pieces, and there we are. That's exactly what happened in 26, except that the upper portion were not present. Now we go all the way to the top. We can make our cross pin. Okay. So for the cross pin, I'm going to say right click, insert, 3D part. Okay, I'm going to call this thing cross pin, properties, cross pin. Okay, copy, paste here. All right, and then we say okay, we're going to make it. And how I'm going to make it is as follows. Let me go to 3D shape. So I can go and make these things independent of what I've done, but I'd rather use the stuff that's there to get the thing going. So on that vertical plane, which means on the XY plane of this thing, I'm going to sketch. Why don't I project? I project one of these circles to make my job easier. I'm going to project one of these circles. It really doesn't matter which one is it that we're doing. Yep, I project that circle. And then I say, okay, notice that the circle has been projected. And then we're going to exit that, and then we pad it. But I will do it, first of all, I'll do it from plane to the next plane. Okay, I guess up to plane, up to this plane. Okay, and then for the second limit, also do it up to that plane, up to this plane. So it's just like as if I've done symmetrically. Now, what I want to do is I want to make a pattern of this because I need another piece which is exactly 90 degrees to that. There are different ways of doing it. We can use the pattern, the circular pattern. So let me see if I can find it. Transform rectangular pattern, circular pattern, and I want a complete crown. So this is the reference element is going to be, for example, I need it, not the whole solid. I just want this pad. I just want this pad. Reference element, for example, this circular face. Okay. Sorry. Yep. And then 90 degrees. We're going to find out whether it looks right or not. So let's see now. Complete crown. Complete crown. Two of them. 180 degrees preview. Uh, it could be that that surface is not going to be very. We'll make it instead of complete crown, I make it two of them, and I make 180 total angle 360, two of them. Let's see what it looks like. Cancel that. All right. So what I want to do is to create a circular pattern here. So I found a circular pattern, uh, not the whole solid. I just want this pad. Okay. And the reference is going to be this vertical axis. Complete crown. Let's see if this thing works. And okay, so I don't want. I just want uh, two, maybe one. It's not. So let's go ahead and make it two instances. We can make four instances. Okay, fine. That's fine. And then we say okay. So, all right, obviously you could have made this thing by yourself. The thing that I did not like was that four, but it really doesn't matter. I would have guessed it would have been two. But anyway, that's fine. Now we're pretty much done here. So we go all the way to the top. Notice that I have three parts here: the original shaft, the instance of the shaft, and this cross pin. Now I'm going to do the wall. So same process as in tutorial 2027. So we're going to go to all the way to the top, right click insert 3D part. Okay, I'm going to call this in the ground. That's where the bearings are going to go. Right click properties, you make this thing ground. Ground. I'm sorry, cancel that. Right click properties, ground, and ground. Okay, say fine. Now let's go make it. Exactly like what I did in 27. So on, for example, that sure, on that on this vertical plane, I will sketch. Let's go to that part first. Yeah, I will sketch. Okay, something that on the profile. maybe like that. We may have to change the sizes a little bit later on so that it looks nicer, that's all. So this is going to be my ground exit. Let's create those bearings at the two ends. So why don't I do the following? Um, uh, Create a plane, normal, normal to a curve. This is the curve and that's the location. And do another one on the other side. A plane normal to the curve and this is the location. And let's go draw the bearings. So on that vertical plane, I will sketch two circles. One of them is for the whole of the bearing. Something like this, maybe. And another one which shows you the outer surface of the bearing, right there. Exit. And then we're going to pad this thing. I'll make this thing 10. Okay, very good. Do exactly the same thing on this side. On that side plane, the sketch. A circle. And another circle. Okay. Exit. Pad it. Okay. I'll make this thing 10. So it looks nicer. Good. We are pretty much done here. As a matter of fact, I can move these things apart so that you can see what's going on all the way to the top, all the way to the top. And let's quickly save. Okay, so using manipulate, move these things apart. So manipulate, translate. You know what? Before I do that, let me fix the ground. That doesn't go anywhere. So we're going to fix the ground. Okay, right there. And now manipulate. Why don't I do a translation in the direction? I'll see. I think that's going to be X. Okay, so let's see now. This is one of the shafts. Here's the other shaft, and here is sure uh, the crossway. Okay, now let's assemble it. Now what I'm going to do, use the snap feature. Okay. By the way, you can change the size of these axes by going to the preferences, but I'm not going to bother doing it. Okay. Now I'm going to use the snap feature. Snap. Let's do it very carefully. So this axis and that axis. Okay, and I want to bring this point and put it right at that junction point. Okay, so let's see now. I want another snap between, well, that's done. So another snap between this point and this junction point. Good, very good. And then do the same thing with the other fellow. So snap between this axis and that axis, and snap between this point and that junction point. Okay, very good. Why don't we do a little bit of rotation here so that it looks better? So we go to manipulate, rotate about this axis. You can see that. Let me turn this thing. Yep. Okay, very good. Good. So now we're going to do our constraints. So first thing I'm going to do is, oh, don't worry about this thing. We're going to put this thing in there later on, okay? So save everything first of all. Now notice that these bearings, I could have made it shorter. In fact, if you prefer, I can go to that sketch. Make that thing a little longer. Actually, let me undo that. Let me undo that. Actually, I'm going to dimension it. Maybe it's easier. Uh, I'll make it 200, 210. Okay, that's good. And same thing on the other side. Just looks nicer, that's all. Make that thing to, I don't know, to 230. Okay, exit. Well, actually, I wanted to make it shorter, not longer. Go back there. Go back to that sketch. I want to make shorter. So we make it 9190. Maybe even shorter than that. And 150, 140, 145, it doesn't matter. Yeah, and same thing with this one. 145. These numbers don't mean anything. Exit. Yeah, it's more respectable. That's all. All right. So let's go ahead and assemble stuff. First of all, this one I want it to be a cylindrical joint, right? So what I'm going to do is go all the way to the top, all the way to the top, cylindrical, exactly the step that we did in tutorial 27. So the axis of this and the axis of the bearing, and I don't need to control these things, so I'm going to delete that and delete this. So there's going to be a cylindrical joint right there. Then I do a revolute here. So revolute, I'll do the second one, offset, axis, offset of two plane and angle. So what do I mean by that? So it's this axis and the axis of this bearing, the offset between that plane and this plane, and the angle. Now here you have to be a little bit careful. The angle between, this is the vertical plane of the shaft, I hope so. Okay, so let's see now. This is the vertical plane of the shaft, yes. And I need, for example, the vertical plane of the ground. If there is, as the ground, the vertical plane, yep, you can see that. This is the same vertical plane. Okay, whatever that angle. Oh, no, not that one. Well, actually, it doesn't matter. You can use that too. I was going to use the vertical plane, but it's okay. This one will work for me. It's the angle between these two. Fine. All right. Now, the universal one, but maybe I place this, what is that? I place this thing in there. So that's going to be, I'll make it a how about two, let's make it two cylindrical ones. If necessary, we're going to come back and fix it. Okay. So coincidence, not coincidence, but two cylindrical one. Where is that? Cylindrical one. If necessary, we change it. We can use this or that, doesn't matter, because all we need is the axis of this and the axis of that. Okay, and yeah, and delete this fellow and delete that fellow. Okay, and another one between this guy and that guy. So another coincidence, sorry, another cylindrical between this axis and that axis. Good. And then that's pretty much it. Get rid of this, get rid of that, and then we say okay. All right. One thing that I don't like is that these are not quite lined up. So I don't like that. The top one is okay, but these are not lined up. So let's find out what we need to do. Yeah. So this joint that I made here, uh, this is fine. Where is that? These are the two cylindrical ones. Let me update first of all. Okay, now it was lined up. That's okay. I just had to update. That's pretty much it. Okay, very good. Last thing that we need to do is our a universal joint. So we go here to universal joint, axis and axis. We have two axis system. One is this one, the other one the other fellow. You can select it from the tree if you want. Look here, it's in the shaft. If you want, so you can select it from the tree, or we can select it from the screen because they're instances of each other, right? And well, if necessary, we're going to come back and fool around with these things. Okay, so here's what we're going to do. We're going to go to mechanical system design, create our mechanism. Let's check our joints. There we are. Now, all right. Okay, let's try it. Okay, let's try it by clicking on the mechanism player and see what happens. One thing is that I don't like the fact that there is a yellow an orange exclamation mark here. But let's move the sliding bar, see what happens. Okay, you see there's some motion. You can see that there is motion, but it's not really what I'm looking for. And the problem is this. The problem is that in tutorial 27, I showed you that you can do this problem without the cross pin. So let's take out the cross pin. Let's go here. Let's take away the cross pin, which is these two cylindrical joints. And we say, okay, and let's now try it. Sure, this is just like 27. The pin is not moving. Reset. This time, let's go back and include the cylindrical joint by take away the universal joint. And then say, okay. Close a mechanism player, once again, green check mark. So you can see that if you take away the universal joint, everything works the way it's supposed to be. The physics is correct, okay? But not when you put them both together. So, yeah, you got to be a little bit careful because it was reasonable to expect that when you put the crosspin and put those cylindrical joints there, it would work. But it seems that there is an inconsistency, something breaks down. Okay? Good luck.